Welcome everyone. Lecture in Polytechnic, Computer Engineering Data Communication എന്ന സബ്ജക്റ്റിൻ്റെ പുതിയൊരു വീഡിയോയിലേക്ക് എല്ലാവർക്കും സ്വാഗതം. ഇന്നത്തെ വീഡിയോയിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത് അനലോഗ് ഡിജിറ്റൽ കമ്മ്യൂണിക്കേഷൻ ഡിഫറൻസ്, ദെൻ ISO-OSI ആർക്കിടെക്ചർ ആൻഡ് TCP IP മോഡൽ. ഫസ്റ്റ് നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് അനലോഗ് ഡിജിറ്റൽ കമ്മ്യൂണിക്കേഷനെ പറ്റിയാണ്. സോ അനലോഗ് കമ്മ്യൂണിക്കേഷൻ എന്ന് പറയുമ്പോഴത്തേക്കും അനലോഗ് സിഗ്നൽസ് ആയിരിക്കും യൂസ് ചെയ്യുന്നത് ഫോർ ദ ട്രാൻസ്മിഷൻ ആൻഡ് റിസപ്ഷൻ ഓഫ് ഡേറ്റ. Okay, so analog communication uses analog signals for transmission and reception of data, while digital communication uses digital signals for transmitting and receiving data. Analog signals are the continuous time varying signals. Digital signals are those which consist of discrete values. Discrete values വരുന്ന signals and digital signals. Analog signals continuous time varying signals. Okay, so periodic signals analog signals an example. So sine waves, okay, sine wave adella periodic signal. Analog signals in example. Then digital signals എന്ന് പറയുമ്പോഴത്തേക്കും സ്ക്വയർ വേവ് പോലെയാണ് digital signals നമ്മൾ represent ചെയ്യാറ്. Okay, so these are some discrete these type of signals have some discrete set of values. Then analog communication നമ്മൾ എപ്പോഴും യൂസ് ചെയ്യുന്ന അപ്രോപ്രിയേറ്റ് ആയിട്ട് നമുക്ക് യൂസ് ചെയ്യാൻ പറ്റുന്നത് ഷോർട്ട് കമ്മ്യൂണിക്കേഷൻസിന് വേണ്ടിയിട്ടാണ്, ഷോർട്ട് ഡിസ്റ്റൻസ് കമ്മ്യൂണിക്കേഷൻ ആണ്. സോ ലോങ് ഡിസ്റ്റൻസ് കമ്മ്യൂണിക്കേഷൻ യൂസ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ വി നീഡ് സം അനലോഗ് മോഡുലേഷൻ ടെക്നിക്സ് യൂസ് ചെയ്ത് കഴിഞ്ഞിട്ട് മാത്രമാണ്, ലൈക്ക് ആംപ്ലിറ്റ്യൂഡ് മോഡുലേഷൻ അല്ലെങ്കിൽ ആംഗിൾ മോഡുലേഷൻ ഒക്കെ യൂസ് ചെയ്ത് കഴിഞ്ഞാൽ മാത്രമാണ് ലോങ് ഡിസ്റ്റൻസ് കമ്മ്യൂണിക്കേഷന് വേണ്ടിയിട്ട് യൂസ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. ഓക്കെ, സോ നോയ്സിൻ്റെ ഡിസ്റ്റർബൻസ് ഇൻ ദ കേസ് ഓഫ് അനലോഗ് സിഗ്നൽസ് കൂടുതലായിരിക്കും കമ്പയർഡ് വിത്ത് digital signals. So we will see some a comparison study among analog communication and digital communication. So analog communication and digital communication ഒരു comparison study ആണിത്. So first നമ്മൾ കണ്ടതുപോലെ analog communication എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ uses analog signal for the transmission of information as well as reception of information, and digital communication എന്ന് പറയുമ്പോഴത്തേക്കും it uses digital signal for the transmission and reception of information. Then noise in the case analog communication it is affected by noise, but in the case of digital communication it is less affected by noise. Okay, immune from noise and distortion. The hardwares are complicated in the case of analog communication and less flexible than digital system. But in the case of digital communication, hardware is flexible and less complicated than the analog system. Then here it is the cost wise. When we see the analog communication is low cost, whereas digital communication is high cost. Then bandwidth requirement, low bandwidth requirement in analog communication and high bandwidth requirement in digital communication. Regarding the power requirements, high power is needed in analog communication, low power is required in the case of digital communication. And portability, less portable as the components are heavy, and here in the case of digital communication, more portable due to the compact equipment. And modulations we used here in the case of analog communication is amplitude and angle modulation, and in the case of digital we use pulse coded modulation, that is PCM, okay, or differential pulse code modulation, that is DPCM. Then representation of signal. Analog signals can be represented as a sine wave, as I already shown, and digital signals can be represented as a square wave. And signal values, in the sense, can have continuous range of values in the case of analog signals, and in the case of digital signals it is consists of discrete values. Okay, and the signals for the examples for analog communication include the analog signals എന്ന് പറയുന്നത് voice, sound, okay, the video അതിനകത്തൊക്കെ വരുന്നതെന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ analog communication, analog signals ആണ്. And digital signals എല്ലാം വരുന്നത് യൂസ് ചെയ്യുന്നത് എന്ന് പറയുന്നത് കമ്പ്യൂട്ടേഴ്സിൻ്റെ കേസിലാണ് digital signals യൂസ് ചെയ്യുന്നത്. So this is a comparison between analog and digital communication. Now we will see ISO-OSI architecture. So ISO-OSI architecture, ISO stands for International Organization of Standardization, and this ISO introduced their model called OSI, that is Open System Interconnection. Okay, Open System Interconnection, OSI stands for Open System Interconnection. And in the ISO-OSI architecture we will be having 7 layers. You can see the layers numbered over here. Okay, the first layer is the physical layer. Physical layer is the lowest layer, as you can see in this diagram. Okay, and it is responsible for the transmission and reception of the unstructured raw data from the network. Okay, so that is the first layer, and it is responsible for the transmission and the reception of the unstructured raw data from over the network. And next is the data link layer, and the second layer is the data link layer, and the data link layer will will help in the transmitting and receiving data frames sequentially. Okay, data frames will be sent. So you can see here it is in the data in the form of bits in the physical layer, and here it is in the form of frames. Okay, so data frames will be received and transmitted sequentially in the data link layer. Okay, so the main function of this layer is to make sure data transfer is error free from one place to another place, or one node from another node over the physical layer. Okay, so that is data link layer. Next is the network layer. Network layer, it can act as a network controller also. Okay, network layer act as a network controller, and network layer decides by which route data should take. Okay, so data should take which route, that will be decided by the network layer, and the network layer divides the outgoing messages into packets. Okay, so outgoing messages into packets and assembles the incoming packets into messages from for the higher levels. Okay, so that is done by the network layer. And coming to the next layer, that is the transport layer. So transport layer, it receives the message from the session layer, the upper layer. Okay, converts the message into smaller units, that is data. Okay, the smaller unit is known as the data. Okay, and pass it on to the network layer, that is the below layer. Okay, that is done by the transport layer. So the different functionalities of transport layer include multiplexing, segmenting, splitting, etc. Okay, splitting of data, etc. are the different functionalities provided by the transport layer. Then coming to the session layer. Session layer, it manages and synchronizes the conversation between the two different applications. So that is done by the session layer. Okay, so session layer manages and synchronizes the conversation between the two different applications, and that is done by the session layer. And coming to the presentation layer, when it will receive the data, the presentation layer transforms the data to be ready for the application layer. So that is done by the presentation layer. Okay, and so the presentation layer have the other functionalities like data compression, data encryption, the data conversion, all those things can be done by the presentation layer. Then coming to the application layer helps in transferring the files. Okay, so it is used in the functionalities of services like mail services or directory services, etc. Okay, so that is the functionality, or that is the purpose of application layer. So transferring of files can be done with this layer. So that is the topmost layer. Okay, application layer is the topmost layer. So this is about the ISO-OSI model, and you can see in this diagram the data unit, or the unit name of the unit exchanged in each layer is mentioned over here. It is here it is application protocol data unit, then presentation protocol data unit, session protocol data unit, transport protocol data unit, then packet frame bit. Okay, and the protocol used in each layer is, here it is application protocol, here it is presentation protocol, here it is session protocol, this is transport protocol, here it is network layer host router protocol, data link layer host router protocol, then physical layer host router protocol. Okay, so these are the different protocols used in each layer. Okay, so this is the diagram showing the ISO-OSI architecture. And coming to the TCP/IP model, so TCP/IP model was introduced before the ISO-OSI model. Okay, so we will see in detail about the TCP/IP model. So it got different layers, as you can see in this diagram. So we will see each one. So network access layer include these data link layer and the physical layer. Okay, so network, then comes the network layer, that is the internet layer also. Network layer is also known as the internet layer. So it includes different protocols you can see over here. Like one protocol is the ARP protocol. ARP protocol is address resolution protocol. Okay, it is a network layer protocol, address resolution protocol, and the purpose of this protocol is to find the physical address from the IP address. Okay, so to find the physical address from the IP address, So that is the purpose of address resolution protocol. Okay, and RARP is reverse address resolution protocol, and we have ICMP protocol. So ICMP means internet control message protocol. So internet control message protocol means it's a mechanism used by the host or the routers to send notifications regarding the datagram problems back to the sender. Okay, so if any problems occurs, that will be denoted to the sender back with the help of ICMP protocol. And IGMP is that is Internet Group Management Protocol. Okay, so that is for group management, sending messages to a group or a same from a particular IP address. One message is sent and that can be given to the associated host. Okay, so that is making a group and sending messages so that the message will be delivered to all the members in that particular group. So these are the different protocols in the network and internet layer. Okay. Then coming to the transport layer. Transport layer is the protocols used there, TCP and UDP. So transport layer means the functionality or the responsibility of the transport layer is the reliability, flow control, and all those things are the functionalities or the responsibilities of transport layer. And two protocols came in this transport layer are, one is TCP and the other one is the UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. Okay, Transmission Control Protocol and User Datagram Protocol. And you can see the difference between TCP and UDP, like TCP is a connection oriented protocol and UDP is a connectionless. So that means in UDP it is an unreliable transmission, here it is a reliable transmission. So it is somewhat that message transferring, message sending, here it is somewhat guaranteed and here it is not guarantee of delivery. Okay, so these are and here before sending the messages, here a virtual circuit will be established in the case of TCP. A virtual circuit established ചെയ്തിട്ടാണ് handshaking process എന്ന് പറയും. ഒരു virtual circuit establish ചെയ്തിട്ടായിരിക്കും sender to receiver transmission നടക്കുന്നത്, അല്ലെങ്കിൽ to and fro transmission and reception of data നടക്കുന്നത്. So ഒരു virtual path, ഒരു connection, നേരത്തെ തന്നെ ഒരു connection establish ചെയ്യുന്നതുകൊണ്ട് we can say that the delivery is guaranteed and it is a reliable form of communication. So TCP guarantees a reliable form of communication. So these are the differences between TCP and UDP. Coming to the application layer. So application layer, it allows the user to interact with the application. So that is done by the application layer. Okay, so application layer is having different protocols, as you can see over here. The main one is the HTTP protocol, and HTTP allows to access data over the World Wide Web. Okay, Hypertext Transfer Protocol. HTTP stands for Hypertext Transfer Protocol, and Hypertext Transfer Protocol is responsible for allowing the access of data over the World Wide Web. Then comes the SMTP. SMTP is the Simple Mail Transfer Protocol. A Simple Mail Transfer Protocol helps in the process of mail sending and receiving mails, and FTP is File Transfer Protocol, that is helpful in sending and receiving files. Then Telnet is it is a short form of terminal network, and it establishes the connection between the local computer and the remote computer. That is done by the Telnet. Then DNS is domain name system. SNMP stands for Simple Network Management Protocol. Okay, then we have other protocols. These are the different application layer protocols included in the TCP IP model. And we will move on to the model questions. So first question is NTFS stands for. NTFS stands for, actually the full form is New Technology File System. So the correct answer is option C. Next question, in the TCP IP suite of protocols, which of the following is the exact purpose of the address resolution protocol? Address resolution protocol is ARP. Okay, and ARP is used for convert IP address to the physical address. So the correct answer here is to determine the hardware address of a given IP address. So an IP address in the physical address and hardware address determine use. Okay, so the option D is the correct answer. Next question, the transport layer protocol used for real-time multimedia, file transfer, DNS, and email respectively are. So real-time multimedia transfer is guaranteed protocol. So we can use UDP for this. Okay, and file transfer we need a guaranteed protocol TCP and DNS also. DNS means domain name system. So here we need to convert the name the IP address to a particular domain name. So for that we need a we don't need a connection oriented service or a reliable service. So here we can use UDP, and in the case of email we need a connection oriented service like guarantee delivery we require. So you can use TCP over here. So the option here it is the option C. So this is the correct answer. Next question, a host is connected to a department network which is a part of university network. Okay, a department network, and here is it is connected to a university network, and university network in turn is a part of internet. Okay, it's a part of internet. So part of internet. The largest network in which the Ethernet address of the host is unique. So the largest network here is the internet itself. So the answer here, options here is the subnet to which the host belongs, the department network, the university network, the internet. So the answer here is the largest network here is the internet. So option D is the correct answer. Next is in TCP, a unique sequence number is assigned to each. Here it is each message. Okay, for each message unique sequence number is assigned in the case of TCP. Option B is the correct answer. Then which of the following is not an ICMP command? ICMP is Internet Control Message Protocol, and which command is not a part of ICMP? The answer here is the ifconfig. Okay, so the ifconfig is not a part of ICMP command, and option C is the correct answer. Next question, which of the following is an application layer protocol? Here the application layer protocol, as already we have discussed, is HTTP is the application layer protocol we discussed. It is hypertext transfer protocol. Option D is the correct answer. So with this we will wind up. Thank you.